All right, guys, can you hear me now?
Yes, sir.
All right, thank you very much. Maybe my earphones had a problem there. Okay, so today we are going to look at cubic functions. We are going to look at cubic polynomials. We are going to look at number 2. Now we'll go to the cubic functions. Then we are going to look at sketching. Then we are also going to end by looking at determining the equation given a sketch. Okay, determining the cubic function given the graph. Okay, so we are going to look at cubic polynomials. We are going to look at sketching. We are going to look at determining cubic functions given the graph. Then I hope we are going to be able to solve one or two of the questions that I've sent there, because it's quite a lengthy topic. Right, so we know that cubic functions are from cubic polynomials. Okay, so the first thing that we are going to look at is cubic polynomials. We know from our knowledge of polynomials, a polynomial is actually an expression that is two or more terms. Okay, so for it to be a cubic polynomial, the highest term of x should be 3. Okay, so the first thing that I want us to talk about is factorizing cubic polynomials. Okay, right, so for us to be able to factorize, we use the factor theorem. What does the factor theorem say? The factor theorem says if we are given f of x, right, then f of negative b over a, if it is equals to 0, then ax plus b is a factor of f of x. Okay, so if negative b over a, right, is equals to 0, of which b and a are integers, they are numbers, if it gives us 0, then ax plus b is a factor. So we use the factor theorem in order to find the first factor of a cubic polynomial. Okay, we use the factor theorem in order to solve the cubic polynomial. So it is very important. We use factor theorem to factorize and eventually solve cubic polynomials. Okay, right, now let me go into the gist of things. I want to deal with the factor theorem and eventually factorization of cubic polynomials by looking at an example. Okay, so the way we solve cubic polynomials, for example, e.g., let's say we are given x cubed, or f of x is equals to x cubed minus 2x squared minus 5x plus 6, like that. That is a cubic polynomial. Why is it a cubic polynomial? Because the highest power of x there is 3. Then this one becomes a cubic polynomial. Okay, so for us to be able to find the first factor, who wants to tell us what we do? Guys, I mustn't talk alone. Today I'm not putting on earphones, so it's difficult for me to understand whether I'm with you or not. So what do we do in order to find the first factor?
We can rewrite the expression.
Like how?
Like x to the power 3 minus x to the power 2 minus x to the power 2 again. And then this one
All
will
right.
give me...
I think you want to use synthesis in order to find that. Let's try to find the factor theorem. Right. Let's try to do f of 1 and see what we get. Right. If you have a calculator at the end there, try f of 1. So where there's x, we're going to substitute by what? By 1. Okay. So it means 1 cubed minus 2, then 1 squared minus 5 in brackets, you substitute by 1 plus 6. What do you get? What do you get? Do you have your calculators at the end, guys?
I got 0. Don't know if I've done it right.
You got what?
0.
You got 0. Yes. So what does it mean? What do we have in place of a and a negative b minus, over a? We have 1, right? Which is positive 1. Therefore, it means x. Now, when you're taking it to the expression, it has to be minus 1. So it means f x minus 1 is a factor. X minus 1 is a factor because f of 1 gives us what? Gives us 0. Right? F minus 1 is equals to 0. So x minus 1 is a factor. So since now x minus 1 is a factor, now we have to use that one in order to solve that one. So we are going to say x cubed minus 2x squared minus 5x plus 6 is equals to the first factor we have it, which is x minus 1. Now we need to find the second factor. So how do we find the second factor? In order to find the second factor, divide x cubed by x. If you divide x cubed by x, what do you get? You get x squared. Then you divide 6 by negative 1. X divided by 6 divided by negative 1, what do you get? You get negative 6. Okay, so if you divide, if you do like this, you're going to get a cube. What do you call it? A trinomial this side. So we want the second term. How do we get the second term? That's the thing. How do we get the second term? So in order to get a second term, this is simple. Multiply this one by that one. You multiply the 2. Then if you multiply negative 1 times x squared, you're going to get negative x squared. Then leave a space and put a bar like that one. Take the term that is actually having negative x squared. That is having x squared there. So you're going to take this one, you bring it down there. That is going to be negative 2x squared. Ask yourself, if you are having this term, to get the next term here, what do you need to do? What do you need to add that side so that you can get this one? Okay? So in order to do that, it's simple. We have to actually do reverse. So take this term here, take that one, subtract that. Subtract that. So I'm going to do it aside. This is going to be negative 2x squared minus, in brackets, negative x squared. So if you do that, negative 2x squared, this is going to be plus. So it means we also need negative x squared, because negative 2x squared plus x squared gives you negative x squared. Okay, so what do? You take that one, you divide it there, then the result, you put it there. So this is going to be negative x. So this is pretty easy. How do you do that? To do that, you multiply this one times that one, you get that. You bring that one down there, you take this one and divide there. Then when you divide there, you take this one, you subtract there, then you get this one. After getting this one, you just remove the square and put it there. Okay? So now, what does it mean? I'm going to rub here. What it means is that now this is going to be equals to x minus 1 in bracket, then x squared minus x minus 6. Right? So we can further factorize this x minus 1. Then in brackets there, we can get that this one, we have x, two numbers that if we multiply, they give us negative 6, but if we add, they give us negative 3. That is going to be, negative 1, that is going to be negative 3 and positive 2. Negative 3 times that, negative 6, negative 3 plus 2 gives us negative 1. So we have fully factorized it. If we're asked to solve it, it's x minus 1, x minus 3, x plus 2 is equals to 0. Then from there, x minus 1 is equals to 0, x minus 3 is equals to 0, x plus 2 is equals to 0. And x is equals to 1, x is equals to 3, x is equals to negative 2. Those will be the solutions. To find whether this is correct, you can try to put this one there. F of 3, you should get 0. F of negative 2, you should get 0. That means that this one are also what? Factors of this trinomial. Okay? Let me try to do another one. And I'll try to do it slowly, and I'll try to write the steps downwards. Only that my board is small. I'll try to write the steps downwards. Okay? Right. For example, another one, number 2. Factorize f of x is equals to x cubed plus x squared minus 16x minus 16, like that. So the first step is to determine the first factor. So what do? We are going to do it by trial and error. You have to try f of 1. You have to try f of negative 1. Let's say you didn't get this one, you try f of negative 1. You have to try f of 2. If you don't get this one, you have to try f of what? Negative 2. Going onwards until you get the factor. Okay? So we always have to start from f of 1. Let's check f of 1. What do we get? So you have to substitute there for x. That is going to be 1 cubed plus 1 squared minus 16. Then you have to put in brackets 1 minus 16. So I get that f of 1 is equals to negative 30. Guys, is this a factor? Is x minus 1 a factor or not? Let me hear from you. Is it a factor or not?
It's not. It's not.
Not
It's not. Otherwise, it was supposed to give us what yet?
0.
So we have to try the other one, which is f of what? Negative 1. Okay? So if we, that one will be simple. Just take your calculator there and put negative in front of 1. Negative. Okay? Then we get that f of negative 1 gives us what? 0. So what is the factor? The factor is what? If it was negative, yes, going to be what?
Plus
1. So it means x plus 1 is the what? Is a factor. Okay? So now factorizing x cubed plus x squared minus 16x minus 16 is the same as the first factor. We know it, x plus 1. Then the next factor, just open a bigger bracket because you don't know whether it's going to be a trinomial or it's going to be a binomial. So divide x cubed divided by x. What do you get? First term you divide by first term here. The last term you divide by the last term. Okay? What do you get? X cubed divided by x. Divide. Divide. What do you get? X cubed divided by x?
X squared.
X squared.
X squared. Negative 16 divided by 1?
Negative 16.
Negative 16. Okay? Then from there, you multiply the 2. 1 times x squared, x squared. Then leave a space. Take this one. What we have here? We have x squared. X squared minus x squared. We have what here? 0. So it means in between there, we have what? 0. So it means
Sorry,
f of x.
sorry, sir. Can you go back a little?
Yes?
Can you go back a little bit? I didn't hear properly what you were saying.
All right. The division, you understood it, eh?
Yes, the division
this
is
one and
okay.
Then
Yes.
multiplication, this one times this one. 1 times x squared. This one, these two. 1
Okay, I
that one.
see.
Then you leave a space. You take this one. You take it down to come here so that you can get x squared here. Did you see it? So what do we need to add to x squared in order to get x squared? We need to add what? 0, isn't it? X squared minus x squared is what? It's 0. So it means also here there's what? There's 0. You get that? Because here what we're supposed to take is what you get here. That is what you put here. After dividing it by x, after removing the square, you take it here. So it means f of x is equals to x plus 1 and x squared minus 16. Then if you can check, this is differences of 2 squares. Then we have x plus 1. Then this one is x plus 4 and x minus 4. That's the difference of 2 squares. X squared and 16, they are perfect square, and you know how to factorize perfect squares. So that is factorizing of what we call cubic polynomials. I want to do another last example before I go to cubic functions. I want to do another last example. Right, the last example that I'm going to do is going to be done by you because I'll be asking you questions to make sure that we have understood. So the last example says factorize g of x, or this one is saying solve now. Right? Oh, this one is a bad example because it's like the last one. Okay, it says solve 4x cubed minus 8x squared minus x plus 2 is equals to 0. Let's quickly find the factor. F of 1. What does f of 1 give us? So it means you take the calculator. I hope you're also doing, guys. 4 multiplied by 1 cubed minus 8, then multiply by 1 squared minus 1. Put it in brackets, right? Plus 2. Then there we get negative 3. So it means this one is not a factor. So try f of negative 1. Check there, just putting a negative. This one gives us -9. That's not a factor. Right? Try 2. Then we see that f of 2 is equals to 0. So this one is not a factor. This one is a factor. So therefore, x minus 2 is a factor. So it means 4x cubed minus 8x squared minus x plus 2 is equals to, the first factor is x minus 2. The second factor, we don't know it. That's the one that we need to find. So what we do, the first term here, it has to be divided by that. So 4x cubed divided by x, what do you get? We get 4x squared. Positive 2 divided by -2, what do you get? Now positive 2, yeah? Divided by -2, what do you get? You get -1. Okay? So after getting -1, now what we need to find the third term here. Multiply -2 times 4x squared. What do you get? You get -8x squared. Leave a space. What do we need to add there? Let's get this one. What do we get there? We have -8x squared. We have brought this one down. Okay? So if we check, what do we need to add there in order to get that? It is 0. Right? So in order to get this one, we can just say this one minus that one. So this one minus that one, it's 0. So it means here, the middle term is 0. So this one is easier, guys. It's 0 there. So after that, I now know that I'm having x minus 2 and 4x squared minus 1 is equals to 0. But this one still is differences of 2 squares, so I can solve it. That is x minus 1. Then difference of 2 squares, 2 brackets. The square root there is 2x. 2x. The square root of 1 is 1. 1. I add, subtract. So it's either x minus 1 is equals to 0. 2x plus 1 is equals to 0. 2x minus 1 is equals to 0. So x is equals to 1. 2x is equals to -1. 2x is equals to 1. Then we have x is equals to -1 over 2. Then x is equals to also half, like that. We have solved the trinomial.
Can I ask
So
something?
yes, you may.
I don't know. I think I'm a bit confused. How did we get to x minus 1 from the first factor? Wasn't it x minus 2?
Sorry, you're not a bit confused. You're actually okay. Look at what I did here. Look at what I did. So it was supposed to be 2. Thank you very much for that. We have x minus 2 there. We have x minus 2. Then I started putting 1 there. Thank you. Thank you, Jake, for being for concentrating. All right. So the first step, guys, that you need to know is to solve a cubic trinomial. Many, they use calculators. A calculator of mine can solve cubic trinomials. It's faster that way. I hope yours also do the same. It'll be easier to do so. So now I want to go to cubic functions. Okay, let's move on to cubic functions. You need to know solving cubic functions, polynomials, for you to be able to do cubic functions. Okay? Right. So cubic functions are in the form of, they are in form of f of x is equals to ax cubed plus bx squared plus cx plus d. where D is considered to be a constant. Where D is considered to be a constant. So usually the characteristics of cubic functions, if they are on a graph, they have two, usually, not always, they should have two stationary points and also what is called one point of inflection. So we are going to talk about that. Okay, so sketching the graph. The shape of the graph is determined by A. Okay, shape number one. We are concerned about the shape, right? If A is greater than 0, meaning to say it is what? Positive. The graph starts as an increasing function, then becomes a decreasing function, and ends as an increasing function, of which these are considered what? Stationary points, which are turning points. And also, if A is less than 0, meaning to say we are having negative A, then our graph starts as a decreasing function. Tends, go to another point, and ends as what? As a decreasing function. So just to know that the shape, it's easy, right? If A is positive, A is the coefficient of x cubed. If it is positive, then the graph starts as an increasing function, meaning to say the first gradient is going to be positive, then it reaches a turning point, becomes negative, but it ends as what? With positive gradient. So if A is negative, the gradient starts as negative, then it turns and becomes increasing, which is positive, then it turns and ends as what? As negative. Okay, so the shape of the graph is determined by A. Okay, right? Then number 2. So let me just write it there. A positive, then it's like so. Then A negative is like so. Okay, right? Then number 2, the other stuff that we want is x cuts, x-intercept. This one we get it by saying y is equals to 0 and solve like what we're doing. Then we have number 3, we need the y-intercept, which is going to be x is equals to 0. Then number 4, we need the stationary turning points. The turning points, which are also considered as what? Stationary points. Now that is where the application of differentiation comes from. This one, you find the first derivative, then equate it to 0, right? You get what we call the stationary points. Okay, then we also need number 5, the point of inflection. Point of inflection, you get the second derivative and equate it to 0. Point of inflection. So these are the items that you need in order for you to be able to sketch the graph. Now people may wonder, what is the point of inflection? A point of inflection, it is a point where the graph changes its concavity, right? It is where it changes its concavity, right? We have two concaves. This one is concave down, then that one is concave up. I hope my spelling of concavity is correct there. So it is a point where the graph changes its concavity, right? So concave down is like an N, concave up is like a U. So the point of inflection, we get it there in the middle part, okay? So now I want to just do one sketching. I want to do one sketching, okay? An example of sketching says sketch. Sketch the graph of f of x if f of x is equals to x cubed minus 6x squared. It's also a cubic function there, though we are having only two terms. It's a cubic function because the highest power of x there is x cubed. Okay? So the first thing is first. What is the value of a there? The value of a is, somebody tell me?
1.
It's 1. So how is the shape? Starts as an increasing what? Function and ends as what? Increasing function. Okay? Now, x intercepts. This one is easy to solve. I chose this one because it's easy to solve. Y is equals to 0. So you equate the whole function to 0. X cubed minus 6x squared is equals to 0. This one we can't factorize it in a fancy way. We actually have to just take out the highest common factor there, which is what? X squared. Then you're left with x minus 6 is equals to 0. So it's like x squared is equals to 0, x minus 6 is equals to 0. So x is equals to 0 or x is equals to 6. So it means the x cuts, I'm going to write it there because I'm going to rub x cuts, x is equals to 0, and also x is equals to 6. So it has 2 x cuts only, okay, not 3, right? Then now we have to find the y cut. This one, y cut is quite obvious. Y cut, x is equals to 0. Then it means y is equals to 0 cubed minus 6 multiplied by 0, because that's what? 0. So it means also y cut, it's what? 0, 0. So I'm going to write it there. I'm going to rub and write it there so that at least we have all our information. Okay? So it means y cut, we are having 0.00. Okay? Now we go to the stationary points, the turning points. Which are the stationary points? Right? In order to find the stationary points, what do? We have to find the first derivative and equate it what? To 0. Now, what is the first derivative there? That is, what is the first derivative? I get what? From our differentiation? 3x squared
3x
minus 12x. Okay, so it means 3x squared minus 12x is equals to 0. This one is simple to solve. What do? We divide there, we factor out 3x, that's the common factor. Then we get x minus 4 is equals to 0. So it's either 3x is equals to 0 or x minus 4 is equals to 0. So x is equals to 0 or x is equals to 4. So these are our stationary points. So we want the y values. So in order to find the corresponding y values, f of 0 is equals to 0 cubed minus 6 multiplied by 0. This one is obvious, it's 0. So it means the other turning point is going to be what? 0, 0. Then the other one, f of 4, in order to find the other, the y coordinate, 4 cubed minus 6 multiplied by what? 4 squared. What do you get there? If you have a calculator at the end, that is 64 minus 6 multiplied by 4 squared. We get, we get negative 32. Right. So what does it mean? It means our two turning points are 0, 0, and 4, negative 32. Okay. So I'm going to go there. Turning points, we have 0, 0, and we have the other one, which is 4, negative 32, like that. Okay. Those are our turning points. I'm just writing it there so that we're going to use them. Okay. So now the last one that we need is the point of inflection. Remember that our first derivative is equals to 3x squared minus 12x. So the point of inflection is 6x minus 12. You equate it to 0. Okay, so it's going to be 6x minus 12 is equals to 0. Then 6x is equals to 12. Therefore, x is equals to 2. So we find the corresponding y value by saying f of 2, which is 2 cubed minus 6, 2 squared. So what do we get there? 2 cubed minus 6 multiplied by 4, get negative 16. So point of inflection, it's 2, negative 16. Okay, right. Now that we have all these, we go to our graph. We are going to sketch. This is not drawn to scale. Okay, that is 0, that is y, that is x. Let's check what we have. Right, x cuts 0, and the other one is 6, somewhere there. Right, then y cut 0, 0. Turning point 0, 0. The one that we have there, that is 0, 0. Okay, then maybe 4 is around there for the other turning point. Then negative 32 is going to be down there. We assume that that is where we get it for negative 32. Right? Then we're going to find the point of inflection down there. Okay? So this one, it starts as an increasing function. It turns. Where does it turn? It turns here. Then it goes down, it turns there, then it goes up. So we draw it from here. Then it turns, because we know that this one is a y cut, which is also an x cut, which is also a turning point. So it turns there, draw it as a curve, then it goes there. So the point of inflection is somewhere there, where we are going to have 2, negative 16. So this one is 0, 0. There is 4, negative 32. There is 6. So that is our graph. That is how we sketch the graph. So as long as you get the turning point, you get the shape correct by knowing what is happening there, all the turning points, all the cuts, then it becomes simple for you. I wish I had enough time to show you how we do the other one, but we need to move on, guys. So you're gonna see this one on the videos. Okay, any questions? I hope not. Okay, now let's check on determining the equation from a given graph. Determining equation from graph. Okay. Right, determining the equation from the graph, we need that is finding the equation from the graph. Right, there are two things. We can use y is equals to a x minus x1, x minus x2, x minus x3. That is if the graph that we are having is of this nature. Then that is x1, x2, and x3. We are having all the three intercepts there. Then to determine the equation, it's x minus x1, x minus x2, x minus x3. Okay? Or it can be y is equals to a in brackets x minus x1 squared, then x minus x2. That is if we are only having two x intercepts. So this one we use it on this one. We only have two intercepts there. That is x1, that is x2. Sometimes a cubic function does not have maybe it has the x-intercept, but it only has one. Those ones are this nature, x plus p cubed plus q. How are they like? This one are like that, where we are only having one turning point there. Where this one, it's negative p q. So when it goes there, it becomes positive p. Then there we have q, which doesn't change. Okay? So we have three ways by which we can determine the cubic equation. We can determine the cubic function from the graph. All right. Guys, having done this, I want to embark on the questions. There's a lot that we can talk about, but I want us to embark to the question. So quickly, let's try to do question number 1 there. I hope our time is going to allow us and it's going to be easier. We're going to extend our time if we don't finish that, at least question number 1. Okay? So check on your worksheets, guys, the one that I've sent on the group of the cubic functions. Okay? Number 1 says the sketch alongside, that is A1, is f of x is equals to x cubed plus 5x squared minus 8x minus 12. A and B are stationary points of f, meaning to say they are the turning points. Stationary points are the turning points. The tangent to the graph at A casts the graph again at P. M is negative 5Q, is just a point on F. Calculate the coordinates of C, D, and E. What's happening at C, D, and E? Guys, let's interact. I hope you actually have the worksheets. Do we have the worksheets, guys?
Yes, we have it.
All right. What is happening at C, D, and E? That is where the graph cuts the x what? X axis. Therefore, the y is equals to 0. Therefore, we equate the equation, or f of x is equals to 0 at C, D, and E. F of x is equals to 0. So x cubed plus 5x squared minus 8x minus 12 is equals to 0. So what are we supposed to do? We are supposed to use our knowledge of cubic polynomials in order to solve this. Let's try and find the first factor. So you try, let me use a different pen there so that I can rub it. Let's try f of 1. Another one, for us to be fast, try f of negative 1 and see which one gives us 0. I'm going to wait for you guys so that you can give me the solutions. Any solutions on the first one? Oh, so on the first one, I got negative 14. Okay, then let me try negative 1. I get 0.
It's 0.
Yes, I get 0. So this one passes, this one doesn't pass. So we can safely write f of negative 1 is equals to 0. So what is the factor there? The factor is what?
X
X.
plus 1.
X plus 1.
X plus 1 is a factor. Right? So I hope now we know what we are doing. Right? I'm just gonna open the brackets there. So the first bracket is going to have 1. Then the second bracket, x into x cubed, get x squared. 1 into negative 12, it's negative 12. Now we want to find the middle one. What do we do? Multiply there. I'm going to write it in red so that I can rub it afterwards. Okay? Right. What do we get there? X squared. Then the term that has x squared there, I have to bring it downwards. 5x squared. I got it from here. Right? So now, in order to see what I need to add there, in order to get 5x squared, this is simple. 5x squared minus x squared, what do I get? 5x squared minus, just take this one and subtract there. Then you get the term that you have to get there. What do you get? Guys, 5x squared minus x squared?
4x squared.
4x. Yes. Divide that one by x just to remove the square. So here, this is positive. So it's positive 4x. You no longer put 4x squared because you have to divide that one by x. But we can just know that if you're taking it there, remove the square. Okay? So that is simple. We are done the first part of factorization there. Okay? The second part, we have to factorize this one. X plus 1. Then that one, we can factorize it. X. Two numbers that we need to multiply in order to get negative 12. In adding them, we need to get 4. Positive 6 and negative 2. 6 times negative 2, negative 12. Then if it vexes you to factorize like this, remember you can always use the quadratic formula in order to solve that. So we get x plus 1 is equals to 0, x plus 6 is equals to 0, x minus 2 is equals to 0. I mean to say x is equals to negative 1, x is equals to negative 6, and x is equals to positive 2. Okay? So from there, we can see which one is C, which one is D, which one is, they say determine the coordinates of C, D, and E. So we see that C is actually, if you check, if you compare between negative 1, negative 6, and 2, C is what? Negative 6, 0. D is negative 1, 0. And E is 2, 0. So we are done with that. We have used the knowledge of cubic polynomials in order to get C, D, and E. Okay? Now, number 2, that was number 1. Right? Number 2 is saying, write down the coordinates of F. What is happening at F? I'm going to answer myself. F, it's y cut. Therefore, x is equals to what? 0. Therefore, y is equals to 0 cubed plus 5 multiplied by 0 squared minus 8 multiplied by 0, then minus 12. So it means y is going to be negative 12. So it means F is having coordinates 0, negative 12. 0 because it's a y cut, then the value of y there is negative 12. So F is having coordinates 0, negative 12. Okay? Then we go to the next, number 3. Calculate the coordinates of A and B. Calculate the coordinates of A and B. Calculate the coordinates of A and B. So what is happening at A and B? A and B are stationary points. How do we get the x, the x values of the stationary points at A and B? Remember that the gradient there is equals to 0. How do we get the gradient? The first derivative, which is going to give us 3x squared plus 10x minus 8. Okay, I've derived that function. I hope I'm correct. 3x squared plus 10x minus 8. Then 3x squared plus 10x minus 8 is equals to 0. You can always, to save yourself from frustration of factorization, you can always use the quadratic formula. But for myself, I got x is equals to 2 over 3, or x is equals to negative 4. Okay, so I've already done this. So these ones are the x coordinates of A and B. Now, in order to find the y coordinates, go and do f of 2 over 3. Then you also do f of negative 4. Okay, so if we do f of 2 over 3, you are going to get negative 400 over 27. And if f of negative 4, you're going to get 36. So it means we have two coordinates there. The other one is 2 over 3 as to negative 400 over 27. The other one is negative 4 as to positive 36. So comparing between A and B there, which one is A and which one is B? Can somebody tell me which one is A and which one is B there? I think this one is A. Because remember that X is...
Yeah, the A is minus 4 and 36. Yeah.
Yes. Okay, so that is A and that is what? B. So in order for us to get our stationary points, we can use the first derivative equated to 0. Then now solving this one is just solving a simple quadratic equation. All right, so That was problem number 3. That was problem number 3. Okay. Problem number 4. For which values of x is f decreasing? Okay. What is the question asking when you say is f decreasing? We are talking about the what? The gradient. That the gradient is what? Negative. Between which values is the gradient negative? Between which values? Between which values we are talking about? C, between C, A, D, E, F, B, E, or up to P there. This is increasing. That is decreasing. Increasing, we are saying as the value of x are increasing, also the y values are what? Increasing. But now, as the values of x are increasing, the values of y are decreasing. So we have increasing, we have decreasing. Increasing, decreasing. So positive gradient is increasing, the negative gradient is decreasing. Positive gradient, negative gradient. Increasing, decreasing. Okay, so the question is asking between which values of x is, or it's actually saying for which values of x is the function decreasing. Let's check there. Where is it decreasing? From which alphabetical letter to which alphabetical letter? Oh, guys.
Decreasing is from A to
It's from A to B. What are the x values at A? It's -4. What is the x value of at B? It's 2 over what? 3. So it means it's decreasing between these 2 points. It's decreasing between what? These 2 points. I hope you can see there. Can you see? Between here and there. Right? This is x is equals to -4. This is x is equals to 2 over 3. So it's decreasing between here. How do we present that? From our inequalities, what do? X in between, then like that. Let me just write it properly. So we have decided it's decreasing between -4 and 2 over 3. So if it is between any 2 values, you put the x in between, then put less than like that. So it's decreasing like that. Between any 2 values, a region between 2 values, what do? Indicate the 2 values at the end, put x in between, then always the sign is less than. Okay, so for x is less than -4, but x is greater than -4 but less than 2 over 3. That is the region where it is decreasing. Okay, right? Now we go to number 5. Now we go to number 5. Number 5 says calculate the x coordinates of the point of inflection. That is simple. The first derivative, we got it as 3x squared plus 10x minus 8. Now, the point of inflection, remember that is the second derivative equated to 0. So this is 6x plus 10. So 6x plus 10 is equals to 0. Okay, then 6x is equals to negative 10, right? Then x is equals to negative 10 over 6, which eventually gives us something like negative 5 over 3. Okay, so we can say in order to get this one, it's so simple. We have the turning points. The point of inflection is in between the turning points. So the other method, or what do? We take x is equals to, then we take negative 4, we add the other turning point, x coordinate of the turning point is 2 over 3, then we divide that by 2. So if you check that, that should give you the point of inflection. Negative 4 plus 2 over 3 is equals to the answer divided by 2. You still get negative 5 over 2. We take the x coordinates of the turning points, we divide them by 2. So it's like the midpoint between.
Sorry, sir. Sorry, sir. Is negative 5 over 3, not over 2.
Look at me today. I'm somehow making mistakes. Okay, negative 5 over 3. That is what I actually get here, but I don't know where I wrote 2. Maybe I was looking at this 2. Okay, it's fine. Let's move on to number 6. Calculate the coordinates of P. That is simple. Okay, there are things that we need to know. Calculate the coordinates of P. What's happening at P? P is meeting a horizontal line, and that horizontal line, what is the equation of that horizontal line? Okay, that is a horizontal line. How do we know that it's a horizontal line? Because the gradient of that one, remember it's a tangent at A, and A is having a gradient of 0. So it means the line AP is having gradient of what? 0. So remember that for A, we got negative 436, if I'm not mistaken, right? So it means line AP, yes, the equation of y is equals to 36. All the horizontal line, they take y is equals to a certain value. For example, the x-axis is y is equals to 0. Okay, so it means P already is having x that we don't know, and 36 as the what? As the y coordinate. Okay, so here it's simple. What's happening there? We now know that the graph x cubed plus 5x squared minus 8x minus 12 is equals to 36. Okay, because the y value there is what? 36. Now we need to solve for x and find x there. So it entails solving this. X cubed plus 5x squared minus 8x. If we bring 36 there, what are we going to get? Going to get negative 48. It's equals to 0. Now we find the factors. I've already done this. The first factor that I got there was x minus x plus 4. Okay? Was it x plus 4? Yeah. Yes, because remember that we have this one. So it was x plus 4. So in order to solve the next one, I had to go and say this one into that. X squared, negative 48 divided by 4, I get negative 12. Then multiply this one times this one, I get 4x squared. Taking that one is 5x squared. What do I need to get to add 4x squared in order to get that one? I need
X squared.
x squared. So it means here I'm going to put plus what? X, because I have to divide this one by x. Okay? So is equals to 0. Okay, so this one is easy, x plus 4, then that one is x is equals to 0. Factorizing that one, two numbers that if I multiply I get negative 12, if I add I get 1, that is positive 4 and negative 3. So it means we get x is equals to negative 4 and x is equals to 3 after solving that. So obviously negative 4 is the other side, so x is equals to 3 is the other side. So therefore P is having coordinates 3, 36, like that. So this one we can see is for A, so for P it is that one. Okay, so that is how we get the coordinates of P by equating this to 36. But it needs an understanding that since this one AP is a tangent, and it's a tangent at a stationary point is a gradient of what? 0. Okay, so it means that one is a horizontal line, which is going to be y is equals to 36. All right, that was number 6. Now we go to number 7. Number 7 says determine the equation of the tangent of f at m. So remember, the equation of a tangent is always in the form of y is equals to mx plus c. The first thing that we want to find is q. So in order to get q, for us to determine q, we actually do f of what? Negative 5. You find that f of negative 5, for us to find q, that is going to be, in brackets, negative 5 cubed plus 5, negative 5 squared minus 8, negative 5 minus 12. We get 28. So it means m is having coordinates negative 5, 28. Okay? So the second thing that we need is to find gradient. But remember that gradient is given by the first what? First derivative. Right? So the first derivative says 3x squared plus 10x minus 8. So the gradient at negative 5 is equals to the first derivative of negative 5, which is going to be 3 negative 5 squared plus 10 divided by negative 5 minus 8. Then you find the gradient. Remember that the gradient is m, which is that one. Okay? So what you get? 3 into negative 5 squared plus 10 into negative 5 minus 8. I got something like 17, if I'm not mistaken. I got that m is equals to 17. That is the gradient. Okay, we have used the gradient function. Remember that this one is the gradient function. Okay, so we go back there. You see that now we have y is equals to 17x plus c. In order to find c sub m, the point, 28 is equals to 17 multiplied by negative 5 plus c. Okay, then that is 28 is equals to 17 times negative 5. Minus negative 85 plus c. Okay, so c is equals to 28 plus 85. 85 plus 28. It's 113. So it means the equation is y is equals to 17x plus 113. That is how we get it. Don't be vexed Some use y minus y1 is equals to m in bracket x minus x1. It's still the same. It gives you the same. You substitute y1 is 28. x1 is -5. Then you're good to go. So that is the equation of the tangent. In order to get the equation of the tangent, we need m first. Then we do everything else afterwards. Okay? So it goes back to calculus. The last one, which is number 8, says for which values of x number 1. Let me draw the graph there. Let me draw it in a different way. Right, our graph is like that. Okay. Now it's asking for which values of x is f of x less or equals to 0. So when you are talking about less than 0, this is the 0 line. This is greater. This is less. Right? This is our 0 line. So anything down is less. Anything above it's greater. So we see it's from this part, that part, and that part. Okay? Let's check. What did we get for our C? What are the coordinates of C, guys? I can't see my papers here. Let me just try to check the papers. I've been throwing them all over. Okay, this was -6. This was -1. This was 2. Okay, so we see that this part is less. And how do we determine that part? Our x value is here. Then we have to indicate like that. So the first part is x is less than -6. Shade the part that is less again. That is that one. And remember I said any part, remember that there's also saying equals to, so I put equals to. Any part that is between two values, what do? I put x there. Then the signs should face the same side. So if you're using the graph like that, you see that your signs are going to face what? The same side. So this is going to be -1 less than or equals to x less or equals to 2 because of this item. Okay, so it is. So this part is like the part of the inequalities in question number 1. The part of the inequalities in question number 1. So our solutions are these ones. For x, you shade the part. I've shaded the part that is less. There is the part that I've shaded. This part that's going down. Which x values makes this part? It is this x values. Which x values are making this part? It is between -1 and 2. At -1, f of x is 0. At 2, x is equals to 0. That was why I put the equals to on our inequality sign. That was the first one. The second one, it's talking about number 2. It's talking about the gradient of x is greater than 0. Now, remember that this one is what? This means what? Gradient. So they are asking, where is the gradient positive? So the gradient is positive from there to there. And also from there going onwards. Not from there to there. It's from we don't know to there. And from there to we don't know. Okay? So how do we tell this? This one is x is equals to -4. This one is 2 over, was it 2 over 3? If I'm not mistaken, it's 2 over 3. Okay, so we see that this is for x is less than -4. Because from there, going this side, all the values are less than what? -4. And from here, all the values to the right of 2 over 3 are greater than 2 over 3. So the other one is for x is greater than 2 over 3. So remember that this one means gradient. And gradient here, we want gradient that is what? Positive. So where do we have positive gradient? This one. And also there. That is positive gradient. Or if you wanted to actually indicate it in another notation, it was going to be x is an element, then from negative, no, it's not included, so it's negative infinity up to -4, which is also not included. And also x is an element from 2 over 3 up to positive infinity. Like that. So that is another notation of indicating it. Okay? So the other one, which is number 3, the last one, is asking about f of x multiplied by the gradient is positive or 0. Okay? It's positive or 0. Let me just rub my graph so that I can draw it again and we can understand it better. Okay? So I'm going to indicate it like that. That is that. Okay? Now we know that this is -6, -1. Then the other one was 2. That is -4. That is 2 over 3. Okay? So now we are asking the gradient should be positive and this one also positive. Remember that positive, this one is a bit positive is greater than 0. Negative multiplied by negative is greater than what? 0. So we have to check where the gradient is positive and also where the f of x is positive. Okay? For example, from there to there, we see what's happening. Eh? The gradient f of x is positive. Then also the gradient is also what? Positive. Okay? Then from here to here, what can we say? We can see that f of x is positive, but the gradient is negative. Okay? But from this point to that point, what's happening there? We can see that f of x, it's now negative because now we are in the negatives. And the gradient is negative. Okay? But from that point to the other point, f of x is negative because it's still under the x line, but the gradient is positive. Then from here, going onwards, you can see that f of x is positive and also the gradient is positive. So the regions that we want, I'm going to mark it in red. I'm going to mark this one to that one. And also this one to that one. Then from there, going onwards. Okay? So we are going to have a number of regions. This one, they say, or equals to 0. So that part is going to be -6, less or equals to x, less or equals to -4. Because it's between these two. That part again is going to be -1, less or equals to x, less or equals to 2 over 3. Because it's between two regions, which is that one and that one. Okay? Then that part is going onwards. It's just going to be x Now the values of x are going to be to the right of 2. X is greater than 2. So these are the 3 solutions that we are looking at. So here we are looking at f of x, whether positive or negative. In this one, the gradient either positive or negative. And the check, we know that positive times positive gives us what? Something that is greater than 0. For example, positive and positive. Then here, positive times negative gives us what? Something that is less than 0. Gives us a negative. Then here, negative and negative gives us what? A positive. So this one we take it. Then positive times negative gives us negative. Then positive and positive gives us what? Positive. So that is how we interpret it. So the solution, I am going to circle it. These are the solutions. So eventually, guys, that is our solutions. These ones. I know it's a bit confusing, but you need to sit down and look at the video afterwards and see that we've been making sense. Positive f of x is above x-axis. Y above there is what? It's positive. Okay? Then down there, it's negative. All right, guys. I'll hear from your comments whether we are going to continue with the cubic functions, or maybe we have to jump to go to financial mathematics the next time we meet. So guys, I didn't hear any questions. I hope we are covered. Remember to comment with any word that you got from the lesson. And guys, please go and look at the other 2. They help you. I take this one from the textbooks because they are sort of comprehensive. They cover a number of aspects. Than from the question paper, it only covers just a certain part. So guys, if you want us to continue looking at these ones, you can just mention it. Then the next time we meet, we can look at more cubic functions. Otherwise, you have a wonderful night, and don't forget to comment. Thank you very much.